Hi everyone, welcome back to Math with Amala. Let's start a new part of your chapter. Number 4 of grade 10 quadratic equations. The standard form for any quadratic equation whose degree is 2 is x square plus bx plus c equal to 0, where a not equal to 0 and b and c can be 0. Since a not equal to 0 implies x square's coefficient should be always a constant rather than 0. Let's have a question here. John and Jiva together have 45 marbles. Both of them lost 5 marbles each, and the product of the number of marbles they have now is 124. We would like to find out how many marbles they had to start with. Okay, so we have to find the number of total marbles which they were having at the beginning before losing the marbles. Let the number of marbles with John be x and the number of marbles with Jiva be 45 minus x because the total is 45. So x and 45 minus x will be the marble numbers of John and Jiva respectively. Since we deals with the algebraic content along with the quadratic equation, we have to take a variable which is x here. When the 5 marbles were lost, John's x will become x minus 5. Jiva's 45 minus x will become 45 minus x minus 5, that is 40 minus x. Now you can multiply them because there is a hint in the question. Their product is equal to 124. That is 40 minus x into x minus 5 is equal to 124. Then you can distribute them like 40 x minus 200 minus x square plus 5x equal to 124. Now with rearrangement we can get that minus x square plus 45x minus 200 equal to 124. That means the quadratic equation is x square minus 45x plus 324 equal to 0. In the next question, x minus 2 the whole square plus 1 is equal to 2x minus 3. We have to rearrange and make a quadratic equation. And by rearrangement, we have got x square, x terms and the constant terms together. Then you are getting a equal to 1, b equal to minus 6 and c equal to 8. You can continue the same steps for the next question also. After the exercise 4.1, we can move to the solution of a quadratic equation by factorization. For a quadratic equation, ax square plus bx plus c equal to 0 where a not equal to 0, a alpha square plus b alpha plus c equal to 0 implies that alpha is the root of the quadratic equation. That means x equal to alpha is a solution as well as it satisfies the quadratic equation. Now, the difference between zeros and roots, zeros are coming for the quadratic expression and roots are coming for the quadratic equation. Therefore, finding roots of ax square plus bx plus c equal to 0 by factorizing 2x square minus 5x plus 3 into two linear factors and equating each factor to 0. Then you are getting the roots of the equation or quadratic equation. Let's see how we can find the roots of the same quadratic equation by factorization. Here we can use different methods like splitting the middle term, a common factor method or grouping method. Here we uses the splitting the middle term method. The middle term with the variable x is minus 5. So we have to concentrate on minus 5. Before that, you just want to multiply the first term and the last term. That is 2x square into 3. Answer is 6x square. The next step is to find the factors of 6, which on addition should get the minus 5. Minus 2 minus 3 is actually minus 5. Then you can take the 2x outside from both 2x square minus 2x. 2x into x minus 1 will remain there. Minus 3 can be taken out commonly, then 3 into x minus 1. Then 2x minus 3 can be taken out and x minus 1 will come inside the bracket. By equating the resultant with 0, you are getting 2x square minus 5x plus 3 equal to 0. That means the factors 2x minus 3 into x minus 1 equal to 0. If a into b is equal to 0, that implies either a equal to 0 or b equal to 0. Hence, in this case, you can say 2x minus 3 equal to 0 or x minus 1 equal to 0. Hence, we are getting two values like x equal to 3 by 2 or x equal to 1 as the roots of the equation. Now, find the roots of the quadratic equation 3x square minus 2 root x plus 2 equal to 0. Here you have to find this factorization using the splitting the middle term method. Then you can use 3x square into 2, that is 6x square. Then again split it into the form like you are getting root 3x minus root 2 into root 3x minus root 2. Here you are getting something which is multiplied for twice. That implies that x equal to root 2 by root 3 is a repeated value, and that root is repeated as root 2 by root 3 and root 2 by root 3 again. Next topic is nature of roots. The roots of the equation x square plus bx plus c equal to 0 is x equal to minus b plus or minus root of b square minus 4ac by 2a, and this is obtained by some other kind of deductions. Here b square minus 4ac is the discriminant, and according to the discriminants type we are having different number of roots. In the case 1, if b square minus 4ac is greater than 0, you will have two distinct real roots or zeros, and they are minus b plus and minus root of b square minus 4ac whole divided by 2a. And then in the next case, b square minus 4ac equal to 0 implies you will have two real roots, and they will be the same as minus b by 2a and minus b by 2a. It will be repeated like we discussed before in the previous question. As the third case, there arises b square minus 4ac less than 0. That means there are no real roots when it is less than 0. Let's apply these results in some questions. Find discriminant of the quadratic equation 2x square minus 4x plus 3 equal to 0, and find nature of its zeros. Then a equal to 2, b equal to minus 4, c equal to 3. We have extracted a, b and c from the equation. Now b square minus 4ac can be applied directly. Then minus 4 the whole square minus 4 into 2 into 3. The answer is minus 8, which is less than 0. That means there are no real roots. Now we have a question. A pole has to be erected at a point on the boundary of a circular park of diameter 13 meter in such a way that the difference of its distances from two diametrically opposite fixed gates A and B on the boundary is 7 meter. Is it possible to do so? If yes, at what distances from the two gates should the pole be erected? So we are having a figure, and the condition is situated correctly in this figure. It is depicted here. Let us take the difference as AP minus BP, which is equal to 7 meter. Then AP is equal to EX plus 7 meter. We can take it as EX. Then angle APB is 90 degree. AB is the diameter. Hence it is 13 meter. Now by Pythagoras theorem, in triangle APB, AP square plus BP square is AB square. Then we can substitute the values of AP, BP and AB. Then you are getting 2x square plus 14x minus 120 equal to 0. That implies x square plus 7x minus 60 equal to 0 is the quadratic equation. From this, you can deduct a, b and c as 1, 7 minus 60 respectively. B square minus 4ac equal to 7 square minus 4 into 1 into minus 60, that is 289, which is greater than 0. That implies it have two real roots. Now we can find the value of x by the formula minus b plus or minus root of b square minus 4ac by 2a, and you are arriving at the answers 10 by 2 or minus 24 by 2. Answer is 5 or minus 12. So the distance cannot be negative, hence you can take x equal to 5. Find the discriminant of the equation 3x square minus 2x plus 1 by 3 equal to 0. By applying b square minus 4ac, you are getting 0. That means it have two equal roots. Keep practicing and don't forget to follow this channel for more updates. Thank you all for watching the video. Please be stay tuned for the upcoming parts of your classes.